database management and warehousing. This is the one of important topic in the GATE 2026 data science and artificial intelligence exam. Now, these are the table of contents we have. Let we start. First, entity relationship model. The entity relationship model means it is the nothing but the student is the name. It is nothing but an entity. The real world object that we call as an entity. Okay, the attributes means if we have a student, the student have different attributes like name, roll number, age, date of birth, and phone numbers, and id numbers, like the type of that we call as attributes. For the attributes, they have two data of derived, multi-valued and derived. The multi-valued means it is the double oval, it is nothing but phone numbers. For the derived, we using that dashed oval symbol for the age of date of birth. And the relationship, we need to assign the relationship by applying the diamond shape. So this way, the entity relationship model we would be drawn. And next, the cardinality ratios, the table conversion. It means there is a 1:1 It means for the person to passport, that we need to design a relation, that means that in the reference of one table to another table, that is we called as 1:1. And if it is in the relation of one table to another multiple tables, then we called as department to employee. It means we have 10 employees, but in department, under department is 1. So that we take, that we call as 1:n. The student and course, we have the students, we have multiple students and we have multiple courses. That's why it is a m:n ratio. M:n means many to many. Next, the relational model keys. The relational model keys means the super key is nothing but we need to identify the uniquely identifies a tuple. The set of attributes is known as super key. The candidate key means a minimal super key. No subset is a unique to identify. It means it definitely must be followed the all conditions, that we called as candidate key. And a primary key is nothing but the unique element that we need to identify. That's like a roll number and ID that we called as a primary key. The foreign key is nothing but the another table primary key that if we have a table A and a table B, so in the table A we need to call a key. The primary key is present in the table B. That we said that the table A, the table B primary key, that the relation between the table A and the table B is table B primary key that we call to table A, that we called as a foreign key, right? Next, here the relational algebra operations. The relational algebra operations are, these are the important in there is a definite question that will be asked in the GATE exam. So here the operator, the selection is nothing but we need to select rows by satisfying the condition. The condition means where. So here this symbol indicates that the select where. It means the select the rows by applying this symbol. If by projecting, it means by select distance. It means this symbol is equal to this keyword, right? This symbol is equal to this keyword. That is very important. And the next, Cartesian product. The Cartesian product means it combines the every row and rows. The combines the every row of R and every row of S. It means it combines the rows of the R and S tables. And natural join means it is naturally joined with the joining of the attributes from the R and S, so that we called as natural join. The set difference means the difference between the R and S, that difference that we called as set difference. It means the tuples in R we taken but not in S. It means we need to take R but not in the S, that we say that we take it, that we called as a set difference. The division is nothing but R division symbol S. It means the tuples in R associated with all tuples in S. It is very simple. The tuples in R associate with all tuples in S. It is nothing but the R is the relation between all tuples to S. That we definition that we applied this division form. In the GATE exam, there is a tricky question that will be asked. He gave that in the question to find A division B. So the result will be, this is the standard results after applying these terms into multiple ways. So you need to remember this well. Next, tuple relational calculus, TRC. The tuple relational calculus means we know that finite automatas. So at these cases, we need to find out that query language. So the format is T by P of T. The T by P of T means the set of tuples that we called as T and such that the predictable is called as P of T. It must be a true. This is the meaning of T by P of T. This symbol means that there exists. It is used for the joinings in the statements. This is the statement of the for all. This for all is used for the division logics for the special case of purposes in the statements. The question is very simple. He gave that some points, some English sentences. Then he asked write the statement in the symbolic form. That is the question that we majorly asked in the examinations. Next, here you need to remember these points very well. Here these points are very helpful for what is the operation that what we do. From by join, it helps to load the tables. Okay. And next, where it helps to filter the rows. And group by is helps for aggregation operations. And having, it is used for the filtering the groups. And select, the select is used for the choosing columns by expressions. The distinct keyword helps for removing the duplicates. And order by of sort, it is nothing but we need to sort the items. So this is the known as logical order of execution. You need to remember these points and it helpful for the how what is the which keyword does what operations. Next, the special SQL concepts are null handling and like operator and correlated subquery. It is a simple example statement. Let us explain very simple. Count of star, it means that it helps to count the nulls. Then after count of column, it helps to ignore the nulls. It means we need to apply this statement. It helps to count the null values. And if we apply this statement, it helps to ignore this null values. And next, like operator. In the like operator, the percent symbol is include that 0 or more characters. The minus, we include that it has only one character. The correlated subquery. The correlated subquery means the inner query relies on the value from the outer query. It means the inner query is on a value from the outer query. It means we have two query that one query inside in the another query that we call as correlated subquery. A executed one for every row of the outer query. It is be slow. It is a simple example of the self join. The self join simple example is select e.name from employee E and employee M, where e.mgr id manager id is equal to e.employee id and e.salary greater than manager salary. Here this condition says that first, here we observed the employee as a E. From e.name, select e.name from employee E. It means the employees table, it selects that name of the employee. After employee of manager, where it means the employee of the manager, it is in this joining the manager column at this position. So after joining them, the manager ID is equal to M. We assign that employee to the manager ID, then employee ID and the condition is applied and then we says that the employee salary greater than manager salary. Based on this condition, employee salary greater than manager salary, then it helps to retrieve that information table only. This way the self join will be helpful in the SQL statements. Next, finding candidate keys by applying closure method. What first, let I understand very clear what is meant by closure method. The closure method is very simple. First, let I observe that R of A, B, C, D, right? And the it means FD means functional dependency. So, and the functional dependency means A tends to B tends to C, and C tends to A. So, these are our fundamental functional dependencies, right? So, this is our given relation. Okay, we have given these two information. So we need to find the closure properties. First, we need to understand very well the closure properties is applied only left hand side values only. Left hand side means it is left hand side, it is right hand side. The left hand side means A, B, C. We need to apply closure to the A, then B and C. The rule is start with attribute not on RHS of any FD. It means we don't need to start B, C, A. We need to start A, then B, and then C. So then applying the closure to the A, it means in the closure of A, it missing that D is missing. So then we added to A with D, then we got that AD as a super key. So check the minimal. It means A or D a key. No, because AD is a candidate key. Because why we said that the D is not in the form of A, and only D is not a key. Only A is not a key. The combination of AD is nothing but a candidate key. So we need to take AD as a super key and AD as a candidate key. This way we need to find candidate keys by applying the closure methods. Next, normal forms. This is also one another important topic. You need to remember these points very well. First one. So 1NF. The 1NF means atomic values no list by arrays in a cell. It means in a table, if only one value will be considered in the table. If we in the table has multiple values that it is related in the one single table, then 1NF will be failed at this case. So only single value atomic values will be present, that we called as 1NF statement. One first normal form will be applicable. So we need to check this 1NF. The question asking terminology is, we check that it is in, there is a given relation R. So based on the given relation, we know very well this way how this question is happened. This way same question is asking and said that which NNF is the correct relation is satisfied. So we need to find the normal form integration. So first 1NF will be satisfied or not. Let me check by applying that it is, if we have multiple values in the table, then 1NF will be failed. So we need to check that it is not will be happened. Then the next case is the 2NF will be happened, only NNF will be completed after. So we need to check it will be done, then 1NF will be after, then no partial dependency will be occurred. What is meant by partial dependency? I will say simple. AB tends to C. It means AB is where AB is a key and B tends to D. It means very well. If the AB is tends to C, it means the AB is a combination of C, and B is turns to D. It means the B is happened at the two times. So there is a relationship between partial dependency is occurred. So in the 2NF, there is no partial dependency must be occurred. So we need to set up these functional dependencies are available or not. So at this case that if it is not available, then it satisfies that as 2NF condition. If it is available, then it is not satisfied the 2NF condition. And next 3NF. So here the 3NF is very simple. After checking that 1NF and 2NF, then go to 3NF. It must be a 2NF will be valid. After 2NF it successful, then we go to the 3NF. Then 2NF, after 2NF then you go to no transitive dependency. The transitive dependency means the A is coming from B, right? A turns to B and B turns to C. So it means the A is coming from B and B is coming from C. It means the A is there is indirectly we have the relationship between here the A is directly coming from C. So it means if we form this chain of rule at this situation, the transitive dependent will be happened. So we don't in the 3NF, this is not the correct statement. So it means we need to check this will be happened or not. If it is happened, then there is a transitive dependency occurs. The 3NF will be failed. If there is no happens, then 3NF will be successful. After 3NF will be successful, then go to BCNF. This means boys got normal form. In this boys got normal form, the 3NF after 3NF, then go to the strict rule. The rule is the x turns to y. In the x turns to y functional dependency, the x must be a super key. We need to check that the x is a super key or not. At that case, the BCNF will be valid. So this way 1NF we need to check, and then 2NF we need to check. After 3NF check, after then we will go BCNF. Next, lossless join. Lossless join means in the joining of two elements, we need to consider a single element among these two terms. Whether this one R1 intersection R2 then becomes R1, or R1 intersection R2 then becomes R2. This is the condition. The dependency preserving. It means all functional derivatives from the decomposed tables. It means the dependency preserving means we need to preserve the dependency. The decomposed tables that can be derived from the functional dependencies. That is the statement here. Next, file organization, B plus trees. You need to remember some points. The point is all that in the B plus trees that we said that it is a balanced tree. Okay. And next, all data points are the leaf nodes. In the B plus tree, the main condition is all data pointers are the leaf nodes. And next condition is internals only contain keys for navigation. The internal nodes is helpful for the navigation purposes. And why we need B plus trees? The B plus tree is helpful for leaves are linked as a linked list format. Then making range queries. Example, in this range query is helpful for where age greater than 20, it will be very fast for getting the results. So that's why we are using the B plus trees concepts in here. In the order of P, the order P means the maximum pointers per node. For maximum pointers per node, the formula is the maximum keys is equal to P minus 1. Next, hash function. The hash function is nothing but maps key to the bucket address. It means we have the bucket right here. So we have multiple keys. We need to here this is the storage elements 1, 2, 3 and 4 and 5 and 6. So this is a bucket element. What is the size? 0, 1, 2, 3, 4, 5. So this is the size of the 5 bucket. So this is the bucket of our size is 5. So by following that hash function means we need to put the keys into this bucket into without collision will be happen. So we need to resolve the collision. For example, collision means, for example, if we place the value into this position as a 1, the another will be directly placed into 2 at this position. So the collision will be happen these two terms. That's why we need to resolve the collision by applying this linear probing method and quadratic probing method. The linear probing method will be helpful for h of k plus I modulus m. It means that there is a cluster issue will be happened in the linear probing. So this is the reason we go to the quadratic probing. In this quadratic probing, there is no issues that we happen. That's why first we applied that linear probing. Then after quadratic probing will be helpful. So insights. The insights is that the average probes of unsuccessful search is equal to 1 by 2 of 1 plus 1 by 1 minus alpha, where alpha is a, here the alpha is considered as the load factor will be happened here. You need to remember this point. For the average probes of for an unsuccessful search, if you need to search an element, for an unsuccessful search, that will be the, here the average probes, the formula is 1 by 2 into 1 plus 1 by 1 minus alpha. There is a direct question will be asked, this chance. And where alpha is, here alpha is considered as the load factor. Next, here we shown that data transformation. It is nothing but pre-processing the data. It means we need to convert the, for example, we need to convert the A into, we need to convert the A into some another form, like some another format. So it means that answer transformation helpful for, you need to convert the one form of the letter into another form, that we call as data transformation. So here it is crucial for the data science and artificial intelligence paper. Why it is crucial? Because we need to analyze the data, right? We need to analyze the data. So for analyzing the data, we must require the pre-processing the data. Before analyzing, we need to pre-process the data, then we will get the best results. So that's why we are using these data transformation approaches. First, normalization. We need to scale that into 0 to and 1 by applying this formula. The formula is x new is equal to x minus x min by x max minus x min. We need to apply this formula at this case. And next case is standardization. In the standardization, it helpful for the Z-score normalization approaches. Standard normalization will be happened here. So in the standard normalization, the mean and standard deviation, the mean is 0 and the standard deviation is 1. So in this case, the standardization Z-score is Z equal to x minus mu by sigma. This is the formula for the standardization. And next, discretization. It is nothing but binning. So in the binning, the width is must be equal. So it is sensitive to the outliers. Then equal frequency will be happened in the discretization. It is nothing but binning. The sampling. The sampling means we need to take some random data points for the execution process by applying the pre-processing step. This is known as sampling. Schema types, OLAP. OLAP means online analytical processing. What is meant by, before entering into the OLAP, let us explain that schema types. The schema types means we have two types of schema. We have the two types of schema is, one is a star schema. In the star schema, central fact table plus multiple dimension tables is nothing but a denormalized faster query. This star schema is the combination of central fact table plus multiple dimension tables. So this way we need to construct the star schema. After constructing the star schema, these features are denormalized features and faster query approaching. These are the features for the star schema. And next, the Snowflake schema. In the star schema, there is a chance spaces will be high. It means it takes a long storage. It means heavy storage will be taken. That's why we apply that Snowflake schema. In this new Snowflake schema, dimension tables are normalized. So this helps to save the space. So we need to resolve the problem in the star schema by applying the Snowflake schema. And next, OLAP operations. Here below we shown that these four are the OLAP operations. OLAP means online analytical processing. The online analytical processing means we have a historical data of large amount of historical data in your, for example, in our day-to-day life. For example, today there is a lot of data will be happened. It means there is a generated by the humans or machines or something else. But data will be generated in trillions of time as increasing day by day. So it means we need to store the data into multiple forms. That's why these operations will be helpful for the accessing the stored data in the fastest way. So how we access the data? By applying these roll up and drill down operations and the slice and dice operation. These four operations will be helpful for getting the results in the fastest way by applying the aggregation operations of as OLAP operations by applying it. These are called roll up, drill down and slice and dice. These are the operations of the OLAP. And next, here the cube operator. Let us explain very simple. How this cube operator will be helpful in the SQL. Here this is the statement how this way it helpful for the cube operator. The cube operator helpful for the grouping the it means the combination aggregating the all combinations. The all combinations means we have cube of A comma B. It means these are the combinations we have A, B and empty and A comma B. These combinations all will be aggregated, so that we called as a SQL cube operator. And next, the formula for the cube operator of n dimensions is 2 power n grouping sets are, then we get to 2 power n grouping sets. So there is a direct question will be asked. If a cube has n dimensions in the SQL, then what is the grouping sets will be? So the answer is 2 power n. So if it is given 2, then how many grouping sets will we have? 2 power 2. It means 4. That means there is a 4 grouping sets are available. Next, example 1. So in the example 1, the relational algebra is, here this is the query. Find students who enrolled in all courses in CS department. It is very simple. Who is enrolled, how many, find students who enrolled in all courses. How many students are enrolled in all courses in CS department? That is the query we need to find out. So here the table we required is student table and course table and enrolled table. So these are the tables we have. The solution is, first identify the divisor. The divisor we have is course. The course is here considered as a divider, and enrolled we call it as dividend. By applying the division operation we applied at this situation, we find the relation of enrolled students in the all CS department. Next, the query. This is the example 2 for the SQL execution. So here there is no direct get exam direct question will be happened. Here this is the simple explanation for you how this query will be working. That is the concept here. First, where statement will be followed up. So here, first the where statement will be followed up. Who salary greater than 50,000. Then after group by will be happened. After group by, the having will be happened. After having, then select statement will be happened here. So this is the execution flow of an SQL execution. SQL query is executed. This way this flow the SQL query execution will be possible. Next, examples 3 and 4. In the example 3, we observe that we have given the relation and these are the functional dependencies we given, and the key is AC. So it means the key, he directly says that the key is AC. So check A times to B. It means A is the proper subscript of the key AC. So here the partial dependency will be occurred. How I said there is a partial dependency will be occurred? Here very simple. Here the key is AC, right? And here the condition is A tends to B. It means A is the proper subscript of AC. So but here A is tends to B. It means A is the subset of B. It means there is A is relation with, there is a partial dependency with C and B. So there is a dependency with C and B partially. So at this case it failed to NF. So that's why it is in the 1NF form. And next, cube. The cube operator helps for the grouping by cube country and product. So it generates, these are the following formats. Aggregations will be operations by all these steps. The first step is India, laptop and sum. This is the given. And next, these two will be given. And next, only this will be given. Then after, only this sum will be given at these cases. This is all about cube operator. So this is finally of complete database management and warehousing. So be prepared well for the GATE 2026 exam. If you want all these materials completely, so then come to Google Chrome, then search Surya Wave. Then here we got the first website. So let enter into this website. So here we shown that all these resources. Then click sign in. After signing with Google, so then click explore services. Here we shown that all these services are available in this website. So GATE 2026 complete bundle material is available here. Click get started. Then you got the all material access here. Then click on purchase now. Scan this QR ID with your mobile. After scanning this QR ID, then the UTR ID will be generated by after payment will be done. Place this that UTR ID at this position. Then click submit for verification. Let I enter this one. Then the payment will be verified within 20 minutes. Complete resources are available into your dashboard.